Alright everybody, good evening. We're going to be working on the final review here. So there are basically two ways to do this. You can either look at the review and just kind of check to make sure your answers are right, or you can sit there and make sure, kind of walk it through. So if you get stuck on something, you can pull up the review and... Well, I'm just looking at something my dog chewed up, and I'm trying to figure out what it is. Never mind. Okay, so you can look at the review and go, okay, well, I don't know how to do this, so let's look at this. So we're starting off on number one. Now, I will go in-depth on some of them, explain the general principle of them, and then kind of talk quickly through the rest of them. Now, I have a puppy here. She's not a puppy, she's about 7-8 years old, with an injured spine, and so if she starts yelping, I'll try and shut it off as soon as possible, but sounds a little bit like a seal, so if that does happen, I apologize. So, for the first four, these are segment addition postulate questions, which means that the general principle is if I take a stick and break it into 2 or 3 little parts, that the length of all 3 of those, 2 or 3 of those little parts will add back up to the length of the big part. So, on number one, what we're going to do is go, okay, those two, the little short part, h to I plus I to j, should equal h to j. Okay. So now that we have that, that's the geometry portion of it. Now the rest is just algebra. What we're going to do is we're going to substitute hi for x plus 2 plus x plus, it's actually x plus 5, sorry about that, plus x plus 12 equals 9. Combine like terms, we get 2x plus 17 equals 9. Divide both sides, or subtract 17 from both sides, and we get 2x equals negative 8. Divide both sides by 2, and we get x equals negative 4. So we have x equals negative 4. Now notice here that we're not done. So this is a 3-point problem. If you had left it as x equals negative 4, I would have gone back and I would have given you 2 points. So we have ij, that's what we're looking for, equals x plus 5. Or x plus 12, sorry. We're going to plug in that negative 4 for x, and we get ij equals 8. So that's actually our answer. Now, if I wanted to, I could go back and plug in negative 4 for hi, and I get hi equals 1. 5 minus 4 is 1. 8 plus 1 is 9, so that checks. So number 2, same general idea. We're going to go PQ plus QR equals PR. Again, those 2 top parts are going to equal the bottom part. Kind of looks like a smiley face. So, PQ is 2x plus 7. QR is 5. And PR is x plus 9. So now we're going to combine like terms. We have 2x plus 12 equals x plus 9. We're going to subtract x from both sides. So we have x plus 12 equals 9. Subtract 12 from both sides, and we get x equals negative 3. Okay, so we're looking for PR. So we know that PR equals x plus 9. I might put 6 there because that's my answer. And we get negative 3 plus so that's wrong. PR is actually x plus 6. So notice what I did there is I was thinking ahead of time. I can go, okay, 6 minus 3 is 6, 9 minus 3 is 6. But PR is x plus 6, okay? 9, did it again. So we have negative 3 plus 9 or 6. So 6 is actually our answer. Now to double check this, what we'd want to do is go back and plug in a negative 3 here. Negative 3 times 2 is negative 6. Negative 6 plus 7 is 1, so that'd be a 1 there. 1 plus 5 is 6, so that checks. Okay. So 3 TS plus SR equals TR. That gives us 9 plus 2x plus 7 equals, wrong button, equals x plus 12. Combine like terms, we get 2x plus 16 equals x plus 12. Subtract 16 from both sides, we get 2x equals x minus 4. Subtract x from both sides, and we get x equals negative 4. Now we're asked to find 2x here. So we're going to drop it right, or we were asked to find TS here, so we're going to drop that negative 4 in for x. We get 9 plus 2 times negative 4. 9 times 8 equals 1, equals TS. And again, 1 plus 7 is 8. If I plugged in a negative 4 to that bottom one, I get negative 4 plus 12. That gives me negative 8. Or that gives me 8 as well. So it all checks out thus far. Number 4. We have 2x plus 20 plus 4 equals x plus 17. Combine like terms. Move that 24 across, so we have 2x equals x minus 7. Subtract x, and we get x equals negative 7. Now notice here on all these 4 we had x is a negative. It doesn't have to be, but it does go to show. So don't flip out because it's a negative. Remember that x can be negative, just your final answer can't be. So x can be negative, the length can't be. So ED is 2x plus 20. We plug our 7 in for x. So we get negative 14 plus 20, or ED equals 6. So, moving on. Now, 5, 6, 7, and 8, same general idea, except instead of using lengths here, we're using angles, right? So instead of breaking a length into little parts and saying all the little parts add up to the big length, we are breaking an angle into different parts. And for this, remember, we use yellow plus blue equals green. So we know that. So if writing this equation, we know that the measure of VUY plus the measure of YUT equals the measure of VUT. Okay, the yellow angle, the measure of the yellow angle, plus the measure of the blue angle equals the measure of the green angle. Now we plug it in. So we know that VUY equals x plus 15 plus YUT, 150, equals VUT, 15x plus 11. So we've set it up. That's the geometry portion of the problem. And now we're at the algebra portion of the problem, which is we just want to sit there and solve for x so that we can plug it back into the missing angle length. So we have x plus 165. Quick yawn. Equals 15x plus 11. I'm going to subtract x from both sides. I'm going to get 165 equals 14x plus 11. Subtract 11 from both sides, and I'm going to get 14x equals 154. Divide both sides by 14, and I get x equals 11. Now that I know x equals 11, I'm asked to find VUY. The measure of VUY equals x plus 15. Plug in an 11 for 15, and that gives me 26. That's apparently a 6, but I'll actually write it decently. So that would be my answer there. Moving on to number 6, the measure of IHJ. That's this angle right there, plus the measure of, I don't know what's going on here. Oh, right, switched. Okay, so hold on just a second. I wonder if I can do this, if it'll record while I do this, or if it'll automatically stop. Apparently it kept recording. Cool. Okay. So, we have IHJ. That's this angle right here. Plus the measure of JHG. That is this angle right here. Equals the measure of IHG. That's this angle right here. Again, yellow and blue make green. Plug it in. IHJ, we're going to put 130. JHG, we put in 7x plus 5. And IHG, we put in 51x plus 3. So, go ahead, combine like terms. 7x plus 135 equals 51x plus 3. I'm going to subtract 7x from both sides. That's going to give me 135 equals 44x plus 3. Hit the wrong button. Divide both sides by 44 and we get 3 equals x. Now again, we're asked to find what the... Okay, it's okay, girl. We're asked to find what the measure of JHG is. So we know that JHG equals 7x plus 5. We're going to go and we're going to plug that 3 back in. And so we get 26. 7 times 3 is 21. 21 plus 5 is 26. Moving on. So I'm not going to do the yellow plus blue equals green anymore. If that helps you, use it. If not, I do think it's helpful to sit there and go, okay, well, I know you can still write out your equation. You can still write out your geometric statement, which is the two smaller angles equal the big angle. So we have measure of angle GHC plus the measure of angle CHI equals the measure of angle GHI. Substitute. Combine like terms. Combine like terms across the equal sign. Subtract 10x from both sides. Same general idea. So we have 114 equals 19x. Divide both sides by 19. And we get x equals 6. Again, we're looking for GHC here. GHC is equal to 5 plus 10x. That's 5 plus 60. Or the measure of GHC equals 65 degrees. Number 8. Same idea. Measure of angle RSD plus the measure of angle DST is equal to the measure of RST. So then we add them together. And remember, and it's important because up until now, 5, 6, and 7, if we looked at the problem, it was we were adding the first two numbers to the second two numbers, okay? Or we were adding the first two numbers to get the third number. Here, notice we're adding the first and the third number to get the second number. So always make sure that you're not just going that this plus this equals this, right? So we want to make sure that what we're putting down as our equation actually lines up with the diagram. Oh, Coco agrees. Coco says, make sure. Coco's the dog. Anyway, she actually doesn't agree. She's a dog and doesn't know crap about geometry. What? That's okay, girl. Sorry about that. Apparently she does know enough about geometry to scream if I mention her name and geometry in the same sentence. Okay. So, we have 5x plus 7 plus 26 equals 8x plus 1. So again, plus 12. Again, what I was saying is make sure that you're actually looking and matching up the diagram to the numbers and not just copying things in order. Because if I sat there and said that those first two add up to equal that one, I'd be wrong, right? This is also where checking your work can play in. So we have 5x plus 7 plus 26 equals zx plus 12. Combine like terms. Subtraction property of equality. Let's do that again. Division property of equality, and we get x equals 7. So we're going to go plug that back in for 8x plus 12. That's RST. 8 times 7 plus 12. Or 56 plus 12, or 68. So the measure of angle RST equals 68. And that's that. So here, we're looking at the slopes of lines parallel and perpendicular to the given line. So we know that each of these angles, or each of these lines, are written in y equals mx plus b. And m's the slope. So the slope of parallel lines is equal to the slope of perpendicular lines is the negative reciprocal. So negative reciprocal means that if I have a slope of a line is a over b, then the slope of a line perpendicular to that is going to be negative b over a. Flip it upside down, and then go from there, and then change the sign. So if it's negative, we go positive. If it's positive, we go negative. So, number 9, our slope is 9/5. That means parallel slope is the same, 9/5. Perpendicular slope, negative 5/9. And again, how we got that, if the slope is 9/5, the reciprocal of that would be 5/9. And the negative reciprocal would be negative 5/9. Okay, so number 10, we have 4/3. Parallel slope is 4/3. Perpendicular slope, negative 3/4. Number 11, slope is 2/5. Parallel slope, 2/5. Perpendicular slope, negative 5/2. Number 12, slope is 3. Parallel slope is 3. Now, here we have 3. Now, to write that as a fraction, we go 3 over 1. So when we flip that over, the reciprocal is going to be 1/3. The negative reciprocal is negative 1/3. So that's going to be our perpendicular slope. Negative 1/3. Okay, moving on. Second page, look at us. Just 1 down, 7 to go. Okay, so here we're asked to find the measure of the angle indicated. So these are exterior angle theorem problems. Now what this means is that the exterior angle, that's the one on the outside of the triangle, formed by extending the lines of one of the sides of the triangle, plus the sum of the two interior angles, equals the sum of the two remote interior angles. So we have 12x plus 12 equals 7x plus 12 plus 55. 12x plus 12 equals, combine like terms, 7x plus 67. We're going to subtract 7x from both sides, and we get 5x plus 12 equals 67. Subtract 12 from both sides, we get 5x equals 55, or x equals 11, after we use the division property of equality. Now we're going to go, remember, we have to find TPQ. Now, keep in mind, when we're measuring how an angle works, if it says TPQ, that's the order that we go. So we draw a line from T to P to Q, and we look at the angle that forms. That's our 2x plus 12. So we know that 2x TPQ equals 2x plus 12. We know that x equals 11. So we go 132 plus 12, or 144. Same general idea for number 14. 13x minus 10 equals 62 plus 6x minus 2. So we have 13x. We have 13x minus 10. So we have 7x minus 10. Good, I fixed my error. Equals 60. We're going to add 10 to both sides, and we get 7x equals 70. Divide both sides by 7, and we get x equals 10. So, we're looking for TFE. That's 13x plus minus 10, Plug that 10 in there. We have 13 times 10 minus 10, or 130 minus 10 equals 120. Same idea for number 15. 20x equals 13x plus 9 plus 40. 20x equals 13x plus 49. Subtract 13x from both sides, we get 7x equals 49. Divide both sides by 7, we get x equals 7. We're looking for the measure of angle W. That's right there. 13x plus 9. Plug the 7 in, we get 81 plus 9, or 90. So that's a right angle. Yay! Don't know why that's exciting, but it is. Anyway. So, for the measure of angle E, we want to start off by setting up 140 is equal to 7x plus 7x. 140 is equal to 14x, so x is equal to 10. Now we're looking for the measure of angle E, and that equals 7x. So we know that 7 times 10, or 70, is our answer, okay? So here it says, state if the two triangles are congruent. If so, state how you know. So we have 5 different options here. Side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. So each of those, you guys should know these. I don't have, if you want a review on these, feel free to. I'm just going to show you how to do the problems. So here on number 17, we see that we have 3 sides that are congruent. So we can say yes, side, side, side. On number 18, now notice on number 18, they only give us one side and one angle, and that's not a problem. Let's be smart. So we're going to figure out that there's a set of vertical angles there. Remember, I gave you that toolkit to use. We're going to go over that a little bit later. So, but we see those crossed lines right there. So we know they're vertical lines. We know vertical lines are congruent. Right there. So now we have an angle, another angle, and a side. So when we're telling the difference between angle, angle, side, and angle, side, angle, it's important that you guys understand that order matters. Order matters not just in issues like congruency statements, but also in how we're saying, what we're saying is congruent to what. So if we had written angle, side, angle, that would mean that the side that we're talking about would have to be in between. So I did write angle, side, angle. That's wrong. Do I go back and change it? No, I don't. Okay, so notice here. Notice how we have, it should be angle, angle, side. Again, if you look down, I was doing this at 11 o'clock in the morning. 11 o'clock a.m. That's weird. I was doing this during, school. Cool. Good for me, being industrious. Okay, so if we had been talking about angle, side, angle, it would have been the side in between the two angles right there. But because we're going from one angle to another angle, and then to the side, angle, angle, and then to the side, it's angle, angle, side. Number 19 is side, 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 because we have a shared side. When we do proofs, that's going to be referred to as, that shared side is the reflexive property. And then in 20 again, now notice here, we have two sides and an angle in between. So again, notice how I labeled them side 1, side 2. Now notice here, we have two sides and an angle. But for this to match up, they have to be in the same order. Remember, I just said this, order matters. Here we go side 1 to the angle to side 2. Here we go side 1 to side 2, and then all the way around to the angle. Or side 1, the angle, and then side 2. It doesn't really matter which way you look at it. It's kind of the same thing. But look here, side, angle, side. The angle has to be in between the two sides. If we look at the theorem, it says the included angle. If we don't have the included angle, it doesn't count. Number 21. So notice here, the angle formed, look at number 21, that's why I call vertical angles bow tie angles, because when they're looking all nice and pretty like that, they look like a bow tie. So 21, we have angle, side, angle on the left-hand triangle, and angle, side, angle on the right-hand triangle. So notice the side is in between the two angles, therefore it's angle, side, angle, unlike the previous one, which was angle, angle, side. 22. Okay, so we have two angles, or we have one angle and two sides. Well, normally we can't go side, side, angle, and angle, side, angle would require us to have the angle in between the two sides, but we then remember that we have hypotenuse leg. Now, whenever you see a right angle, you should immediately check for hypotenuse leg congruency. Because, well, the only time you can have a hypotenuse is if you have a right triangle. So, moving on to number 23. We have apparently I was really tired or really not paying attention when this happened. So, 23 is side, angle, side. See how the angle right there is in between the two sides? See if we have this over here. We have side, angle. Oh, nope. So we go no. Okay, see how because it's not the included side. So this is the included side because it's the one that's formed by the two congruent sides. Here we don't have that, so we don't have congruency. Number 24. Now notice here we have a shared side. That means that side's going to count for our congruency order. So we have one side, second side, and we got that angle in between. So we got yes, side, angle, side. Now, a lot of people are having difficulty on these next ones, and really it comes down to this. Remember that in an isosceles triangle, the base angles are congruent. That's it. That's the isosceles triangle theorem. This is like the last thing we went over before we started studying for the final. In an isosceles triangle, an isosceles triangle is where two sides are the same. So the theorem says if two sides of a triangle are congruent, if that happens, then the angles opposite those sides are also congruent. And we actually prove that in class. So we draw the little arrows. We go, so if one base angle is 38, the other base angle is 38. Notice that 38 is part of a right angle, so we're going to get its complement right there, 52. And notice that 52 is also part of another isosceles triangle. So that's going to be 52 as well. So that leaves us x. We know that all three angles in a triangle have to add up to 180 degrees. So we go 52 plus 52 plus x equals 180. 104 plus x equals 180. Or x equals 76. Now for the first time, notice that we're just being asked to solve for x, so there's actually no additional work to be done. We don't need to go back and plug x back for anything. We solve for x, it's done. Okay. Number 26, same general idea. We have a isosceles triangle. So the base angles are congruent. So if one's 68, the other one's 68. That means that that one right there is 44. I got that by going 68 plus that missing angle equals 180. So 68 plus 68 is 136. And that means that to get from 136 to 180, we need 44 degree angle. Be right back. So, so we also notice that 44 is one of a pair of vertical angles. So if one vertical angle equals 44 degrees, the other vertical angle equals 44 degrees. That second 44, if we look, we see that that's also a base angle. There we go. Which means that the other base angle is also 44 degrees. 44 plus 44 is 88. 180 minus 88 is 92 degrees. So x equals 92. I'm not sure what just happened there, but okay. I don't know if you guys can hear my puppy snoring. She's actually calmed down, which is good. Hopefully you won't hear me snoring, but there's a 50-50 shot at it. It is a little bit past midnight right now. Okay. Moving on. So here, same general idea. For number 27, 28, we're going to bump up the difficulty a little bit. So 27, we have, if that's 30, now notice I don't need to go and find the other ones because that 30 is part of a right triangle, which means the other part is, or a right angle rather, which means the other part is 60 degrees. That 60 degree angle is a base, which means that the other one is 60. Again, what we want to look for is these markings right there that tells us it's an isosceles triangle. That means that if the sides are the same, the bases are the same. So, now what we're going to have to do is to solve for x, we need to find we're going to find that measure right there. And then we're going to have, once we find that measure, we go and we plug it back in to figure out what x equals. Okay? So it's just a slight additional extra added level of difficulty. Instead of finding for x and then plugging it back in to find the angle value, we're finding the angle value and then using that to solve for x. Okay. So 28. And the measure of angle 2 equals x plus 59. So, here we go. So we know that this is a base angle here. Again, we have these isosceles triangles. So if one's 47, the other's 47. 47 and 47 again, because they're vertical angles. And then, again, that right-hand triangle is also isosceles, which means the measure of angle 2 equals 47 degrees. Plug that back in, we get 47 equals x plus 59. Subtract 59 from both sides, and we get x equals negative 12. Yeah, that's not right. I'm not sure. Again, I'm not really sure what happened there. So it's... Yeah, and apparently I just wasn't paying very much attention to what I was doing. Okay, so we subtract 59 from both sides. We get negative 12 equals x. Okay, number 29. Number 29, the measure of angle 2 equals 6x plus 11. So we start off with 76. And that is a base angle in an isosceles triangle. So we know the other base angle is also 76. 76 and 76 is 154, which means that the remaining angle, 152, rather, the remaining angle is 28 degrees. So because that's 28, the other part of that right triangle is 62. We got that by going 90 minus 28 equals 62. So, now notice here that we got the vertex angle of a isosceles triangle. So what that's going to give us then is that 2 times the measure of angle 2 plus 62 equals 180. How do we know it's 2 times the measure of angle 2? Well, because this is an isosceles triangle, so we know that those two are also congruent. That gives us the measure of angle 2 equals 2 times the measure of angle 2 equals 118. Divide both sides by 2, and we get the measure of angle 2 equals 59 degrees. Go back and plug in 59. Do I come back and do that? I do. Okay. So go back and plug in 59 equals 6x plus 11. Subtract 11 from both sides. We get 48 equals 6x. Divide both sides by 6, and we get x equals 8. Okay? So that's for 29, x equals 8. Now notice here, I actually made a mistake that a lot of you guys make. I found the measure of the angle, and I stopped. It was only after a little bit that I realized that I needed to go back and modify my answer. So, or complete my answer, rather. So I'm actually going to rewind a little bit, and that way we can go through number 30 from start to finish. So we have to start with that 69 degrees. And we know that if one base angle is 69 degrees in an isosceles triangle, then so is the other one. We can use those two 69s to find the measure of the missing angle, or 42 degrees. That 42 degrees will leave the other, its complement is 48. Now notice here 48 is one of the base angles, so the other base angle is also 48. And that is actually the measure of angle 2. So we know that 48 equals x plus 58. Subtract 58 from both sides, and we get x equals 10. Negative 10, rather. So what happened there, because my gibberish made no sense, is I subtracted 58 from both sides, and that gave me negative 10 equals x. Okay, so here this is a little bit different, but find the measure of angle A. So now instead of being given the angle and having to find x, we're going to find x first, and then we're going to use that to solve for an angle. Now what we're using here is the triangle angle sum theorem that all three interior angles of a triangle have to add up to 180. So we know that if that angle is 140, then the one right below it also has to be 140 because they're vertical angles. So we know that 140 plus 2 times 4x equals 180, or 140 plus 8x equals 180. I'm going to subtract 140 from both sides. And I get 8x equals 80, or 40 rather, divide both sides by 8, and I get x equals 5. So I want to go back and plug that in right there, and 4x, or 4 times 5, equals 20. We're then going to do the exact same thing on number 32. We get 70 plus x plus 8, that's this angle right here, plus 6 plus 7x, is 180 degrees. Combine like terms. Use the subtraction property of equality, and then the division property of equality. So we know that the measure of angle A equals x plus 8. We know that x equals 12, so the measure of angle A equals 20. The instructions got messed up here. Basically, I wanted you to, for 33, construct a line that was adding those two segments together. So I was going to have you just put the two lengths together, 34. We are constructing the perpendicular bisector of that segment. And remember, with a perpendicular bisector of that segment, what you want to do is have 2 points on there. Open your compass to more than halfway. Draw one arc. Switch the compass over to the other point. Draw the second arc. And then combine the two. And that's going to give us a perpendicular bisector of the two angles, or the 2 points, the line connecting the 2 points. Okay, so here you should have that little diagram labeling the angles caused by a transversal hitting 2 different lines, 1 through 8, and then explaining kind of the relationships of parallel lines and angle pairs. So we had angle pairs like alternate interior, alternate exterior, corresponding, same side interior, vertical. We had linear pairs, and each one of those was either congruent or was supplementary. Supplementary means that they add up to 180. So for this one, we have a 3 and a 5. 3 and 5, if we looked at our chart, would show that they are same-side interior. Same-side interior are, mysteriously, supplementary angles, which means that we're going to go x plus 121 plus x plus 81, and I know a lot of you guys want to just immediately sit there and write the two values and set them equal to each other, but you got to do it right. And here, what that entails is making sure that you understand that these two are supplementary, which means that they add up to equal 180 degrees. We're going to combine like terms, subtract, divide, okay, again, if this doesn't make sense, ask me tomorrow, or just rewind and watch it again. So on number 37, those are vertical angles, which means they are congruent to each other. So we set up 95 equals x plus 103, subtract 103 from both sides, and we're done. Number 38. Now, again, we have same side interior angles, so they are supplementary, which means they add up to equal 180 degrees. Combine like terms. Isolate the variable using first the subtraction property of equality. Further isolate the variable using the division property of equality. We get x equals -9. If I want to check this, I go and plug it back into each of my two angles, and I'd see that they would be returned to 0 and promote that. So, I'm not really sure what I just said. But we got x equals -9 here. We have 1 and 7. If I look at my chart, that 1 and 7 is their alternate exterior angles. They're congruent, which means they're equal to each other. So we're going to subtract 138 from both sides, and we get x equals -8. Again, totally okay for x to be negative as long as the angle isn't negative. Okay, so for number 40, we have 20x equals 80 because they are alternate interior angles. Divide both sides by 20, and we get x equals 4. Number 41, they are corresponding, which means they are also congruent. So we have 4x plus 14 equals 6x minus 4. We're going to subtract 4x from both sides. We're going to get 14 equals 2x minus 4. Add 4 to both sides. We get 18 18 equals 2x. Divide both sides by 2. We get x equals, put 4. That's wrong. It is, so that's an 18 right there. So that's a 9 right there. Okay, it says find the midpoint of the line segment with the given endpoints. So I'm going to label my points x1, y1, x2, y2, and then I'm going to go get a cup of coffee. I'll be right back. Okay, quick coffee break and I'm back. So, we know that the midpoint we're looking for is xm, ym. We know that xm equals x1 plus x2 over 2. And y sub m equals y1 plus y2 over 2. If you don't know what all those numbers and letters mean, come and see me. I'll explain it to you. So x sub m equals 0 plus 9 over 2, or 9 halves. Y midpoint equals 4 plus a negative 6 over 2, or negative 2 over 2, or negative 1. So my midpoint is 9 halves, negative 1. Do the same thing for 43. x1, y1, x2, y2. That means the x midpoint is negative 9 plus negative 10 over 2, or negative 19 over 2. The y midpoint is negative 3 plus negative 6 over 2, or negative 9 over 2. So our midpoint there is negative 19 halves, or if you wanted to put that at negative 9.5, that'd be fine. Negative 9 over 2, negative 4.5. So when we're looking for the midpoint, when we know the endpoint and the midpoint, we're looking for the other endpoint, the equation we use is x2 equals 2xm minus 1 minus x1, and y2 equals 2ym minus y1. Our endpoints are x1, y1, x2, y2, Not x2, y2, because that's what we're looking for. So we have x1, y1, xm, ym. Plug those into our equations. y2 equals 2 times y1, or x2, sorry, equals 2 times xm. So that's 2 times 10 minus y, or so that should actually be not 4, but 2. Now notice that over here we have a negative, but because we're plugging a negative in there, we have a negative, negative 2, so that gives us a positive 2. Which means that our x2 is 22. Our y2 is 2 times 5 plus 4, so they catch my error. Good. Equals 14. 2 times 5 is 10. 10 plus 4 is 14. So if one endpoint is negative 2, negative 4, and the halfway point along the line is 10, 5, the other endpoint is going to be 22, 14. We're going to repeat that process for number 45. x2 equals 2 times 1 minus 8, or negative 6. y2 equals 2 times 4 minus 7, or 1. So our point is negative 6, 1. And again, what we're saying here is that if I were to graph this really quickly, like, okay, so I have a point here, 8, 7, and that's my start. And my midpoint is 1, 4. That's halfway. What I'm wanting to find out is, where is the other endpoint? And here we'd say it's negative 6, 1. That's where the end is. Okay? So, 46, we have to solve for x, and we are looking for the, where this is a triangle angle sum theorem. We know that all interior angles add up to 180 degrees. So that's how we set it up. Adding all three angles equals 180. X plus 80 plus 63 plus, whoa, can I get away from me? So we have x plus 188 equals 180. Subtract 188 from both sides. I get x equals negative 8. Same general idea for 47. We're going to go 60 plus 90. That's this one right here. It's a 90-degree angle. Plus 7x plus 2 equals 180. It's giving me 7x plus 152 equals 180. We're going to subtract 152 from both sides, and we have 7x equals 28 degrees. Divide 7x by 7, 28 by 7, and we get x equals 4. Same thing for 48 and 49. 55 plus 90 plus 3x plus 5 equals 180. 3x plus 150 equals 180. 3x equals 30, or x equals 10. So again, what we did between this step is we subtracted 150, and this step we divided by 3. Make sure that if you do it to one side, you do it to the other. So for 49, we go 60 plus 40x plus 40 equals 180. 60 plus 40 is 100, so we have 40x plus 100 equals 180. Subtract both sides by 100, and we have 40x equals 80. Divide both sides by 40, the division property of equality, and we get x equals 2. Okay. So these are kind of tricky for some people. What you need to do is you need to sit there and go, okay, well, they give you the theorem that you're supposed to use to prove congruence between the two triangles. Now, each of the congruency theorems that we use has 3 pieces. Side, 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 angle, side, angle. And angle, angle, side. Now, even hypotenuse leg, even though it only has 2 letters, does have 3 pieces. It's got to be a right triangle for it to be a hypotenuse. So, for number 50, AAS, we have an angle right there. We have a side. So we need another angle. So when we're looking at the other angle, what we want to figure out is which angle is it? Is it the black angles or the red angles? Now, it's important that we understand kind of which order it goes in. Because if it was the red angles, look, it would go angle, side, angle. It's not what we want. We want angle, angle, side. So that means we need to show that angle S is congruent to angle J. If we knew that piece of information, then we would know that the 2 triangles are congruent by angle, angle, side. 51, we have a side and an angle. We're missing a second side. So it's got to be the one on the other side of the angle. Remember, order matters. So we need that side RC is congruent to side DC. 52. Looking for side, 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 so we need to know that third side is congruent. So GI is congruent to VX. Same general idea for 53. We need to know that IG is congruent to BD. Okay, and that's that. 54, 55, 56, very much like the other ones we were doing with isosceles triangles, just a little more difficult. Tea? Hold on, let's take a sip of coffee. Again, I'm sorry this is so late. I had a rough day. Not a rough day per se, just a long day. It's currently 1 o'clock, so I'm up here. I'm doing what I can. You will have all day tomorrow with this. So, if we know one base is 75, the other base is 75. 75 plus 75 is 150. That means that vertex angle's got to be 30 degrees. If one of a pair of a vertical angles is 30 degrees, the other one's 30 degrees. Now, watch what I'm going to do here. There are 2 ways that I can do this. Now, here I have an exterior angle. 2 is an exterior angle. 30 and 30 are the remote interior angles. So I can just go that 2 equals 30 plus 30, or 60. Okay, now notice if I did it the long way and went 30 plus 30 is 60, that would mean this angle right here is 120. Those 2 form a linear pair. 180 minus 120 is 60. So now I know that the measure of angle 2 is 60, so I can plug it back in up top. Measure of angle 2 is 60 equals 9x minus 3. Add 3 to both sides, so I have 63 equals 9, or x equals 7. Okay, we got 2 more like that. So we start off with 116. We know that 116 and that base angle form a linear pair, which means they add up to 180, which means that interior one is 64. Got that by going 180 minus 116 equals 64. If one base angle is 64, they're both 64. That means that that vertex angle, 64 plus 64 is 128. 80 minus 128, 180 minus 128 is 52. If one part of a 90 degree angle is 52, its complement, 90 minus 52 equals 38. 38, now, if I know that those 2 are angle x, now I know that I'm trying to solve for x, so I probably should have used y or something like that, but anyway, then I know that 38 plus, see, I go on back and change it to y. 38 plus 2y equals 180. Subtract 38 from both sides, I get 2y equals 142. Divide by 2, and I get y equals 71. So if I know that that's 71 degrees and that's 71 degrees, I know that angle 2 and that 71 degree angle are a linear pair, so I know the measure of angle 2 equals 180 minus 71, or 109. Plug that back into my top equation, and I get x equals negative 10. Number 56. So I know that if that's 108, the interior angle is 72. If that's 72, so notice what I did there. I marked both my base angles from one. Cat's losing its crap right now. So I know that 72 plus 2a equals 180. 2a equals 108, or a equals 51. Or it's actually 54. So if a equals 54, I know that's 54 right there. B is a vertical angle, so b equals 54. I know that 2 times 54 the measure of angle 2. And again, here we have an exterior angle is equal to the 2 remote interior angles. So we know that the measure of angle 2 is equal to 54 plus 54, or 108. We know that the measure of angle 2, so 108, equals 120 plus x. Subtract 120 from both sides, and I get x equals negative 12. Moving on, we're almost done, guys. 57, same idea. Start with 64. Now notice, even though it looks like a vertical angle, it's not, because they're not opposite rays. To be a vertical angle, this side right here would have to be an extension of this line right here. If it's not, you can see that it angles a little bit to the left. Anyway, we know one base angle is 64. The other base angle is 64. Two base angles are 64. Vertex angle is 180 minus 128. That's 2 times 64, or 52. If part of a right angle is 52, the other part's got to be 38. One base angle is 38, the other base angle is 38. Exterior angle equals sum of the remote interior angles, so angle 2 equals 76 degrees. Plug that back up in top. 76 equals 9x minus 5. Add 5 to both sides. 81 equals 9x. Divide by 9, and we get x equals 8. Okay, or x equals 9, I'm sorry. So that's the end of this one. We have then part 2, which is the proofs. Now again, what we're trying to do here, yeah, don't do these. We haven't learned how to do these, so forget about it. The top ones are from the value of each variable. It's the same thing we've been doing. It just takes a little more, make sure you know what you're doing, and that's how those answers are. And I will see you all tomorrow. Have a wonderful evening. Or morning, whatever. Bye-bye.